I think we can just get into it. I think Ed will be joining as well, but we can just get started since we have a crowd here already. So hello, thank you all for joining. Today we will be going through and answering questions that we got from Twitter. We got a lot of questions covering a pretty wide range of topics, so we certainly won't be able to get to everything. There'll probably be follow-up, but we'll get to whatever we can. I guess we should start with intros, but my name is Daniel. I'm a software engineer at Off-Chain Labs. I also do sort of technical communication in terms of writing and documenting and things like that, and focused on integrating tools with the ecosystem. Harry, you want to give your intro? They probably know.
Yeah, totally. For anybody who doesn't know, yeah, I'm Harry. I'm one of the co-founders and of Off-Chain Labs and the CTO as well.
Cool. And AJ?
Hey, I'm AJ, Director of Strategy and Partnerships, focused on building up the ecosystem.
Cool. All right. So let's just dive right in, shall we? So question from Electric Sergey, I guess, asked, what will it take for the average ETH consumer to see the benefits of Arbitrum? Will we need to bridge tokens, etc.? And then there was a meme here included about concern with high gas fees on L1. So this is a good starting point. In terms of the average ETH consumer, so if we assume that somebody is used to using Ethereum, I take it that's what average ETH consumer means. What is it like to sort of use, adapt, deploy it on Arbitrum? And the first thing we can say is, in terms of interacting within Arbitrum itself, it will sort of look and feel exactly like using Ethereum. If you use any of the dApps deployed on our testnet, you saw. It will be even better than it was on our testnet because now that MetaMask has this automatic network switching thing, it'll basically mean you land on a dApps page, you'll just get a little pop-up saying this is an Arbitrum dApp. It'll switch your MetaMask network to Arbitrum, and then you just do your thing. Except you'll have lower fees, which is great. So the one sort of caveat there is presumably you need to get some assets from Ethereum to Arbitrum at some point. If nothing else, you need ETH and Arbitrum so that you can use it to pay for gas, just like you use it for gas on layer 1, which again, the average ETH consumer probably has a general understanding of gas, so that's not too big of a mental leap. In terms of getting your ETH to Arbitrum, so you can always just deposit it directly via our bridge. That just happens trustlessly. That's available. Now the only thing there, this questioner was concerned about high gas fees, right? So maybe even that is too expensive for you. And you're thinking, okay, depositing Ether, that's a layer 1 transaction, that's expensive. Can we avoid doing even that, right? And what we expect to see, but we can pretty much say we will see as the sort of layer 2 ecosystem emerges, is you'll have all sorts of more direct ways of getting onboarded, or I guess I should say indirect, ways that don't involve a layer 1 transaction. The most straightforward being if you're purchasing Ether, say from a centralized exchange, which is most people get it, exchanges will have this option of, okay, withdraw to layer 1 on Ethereum, or just withdraw to Arbitrum, right? And if you get your Ether that way and withdraw directly to Arbitrum, now you can sort of start doing Arbitrum stuff, start using dApps on Ethereum without ever touching layer 1 directly, right? So that's really nice. This similar things we can do of sort of communicating across different layer 2s, from channels to Arbitrum, across different Arbitrum chains, things like that. So other layer 2 infrastructure also provides this kind of shortcut ways of getting onboarded. Even other layer 1 chains, right? We can do some like atomic swap, or I think what the Bitcoiners call submarine swaps. But basically at most, in order to start using Arbitrum, you have to do a single layer 1 transaction. So you have Ether to pay for gas and maybe tokens you want to use, and then you're off. Cool. Okay. Second question from @ending22 on Twitter asks, aside from lower fees, what are some of the more known use cases? I think he really means here benefits. What are the more unknown benefits that Arbitrum can offer? And which of these is the most underlooked? So in other words, we all know that with Arbitrum and with layer 2s, you can save on gas fees. What else does Arbitrum offer other than just gas savings? We'll go to Harry for this one. It's an interesting question.
Yeah, sounds great. There's a fair amount to cover here. Which is nice. So I mean, I think the kind of just to start with the sort of most obvious one to users, and that'll be kind of, and we'll talk more about this a little later, I think probably, is kind of fast sequencing of transactions. In Ethereum, there are a lot of things that are kind of annoying about the Ethereum user experience, but one of the big ones is having to wait for your transaction to get included into a block. and kind of using Arbitrum and using kind of Arbitrum as an L2 with the kind of the main with the sequencer chain, you won't need to do that. And so you'll send your transaction off, and then kind of very quickly afterwards, within kind of a couple seconds, your transaction will be in the chain. It'll be ordered, and you'll have your result. And so that's kind of pretty useful for kind of getting for kind of improving the whole user experience. So that's kind of the first one, and that's the most obvious because people will notice the transaction times being way lower. One kind of that I personally find really interesting is kind of the ability to innovate kind of above and beyond what kind of Ethereum can do in terms of like new features. And so I think a perfect example of that is with how we're handling with how we're handling L2 gas and L2, which is kind of an approach that's quite inspired by EIP 1559, which kind of people have probably seen a fair amount of discussion if you're on Twitter. This is like this huge kind of upgrade to have fees are working in Ethereum that kind of we're hoping will happen relatively soon. And kind of when we were designing how that would work for Arbitrum, we kind of took that a fair bit as kind of inspiration in order to kind of get a lot of the UX improvements that people are excited about in Ethereum in Arbitrum, even before Ethereum gets there. And that's just kind of just representative of the fact of like the in general with Arbitrum, we can kind of take on new EIPs and expand new features and improve the kind of experience of using Arbitrum without waiting around for Ethereum to go through hard forks and improve itself, which is very cool. And then just kind of one last thing to mention, which is kind of a little bit on like a longer time horizon, but I find to be really cool, is kind of doing things like supporting kind of alternatives to the EVM. And so the biggest one here that's kind of on our roadmap is WebAssembly support. Which has the advantage, which when we get there, we'll have the advantage of being able to write smart contracts using kind of traditional languages rather than using Solidity, and also with higher performance. And so kind of there's a lot of cool stuff that could be done with like not even just like innovating in terms of like what the protocol is doing, but innovating even in terms of like what languages and people are using to write smart contracts. So a lot of cool stuff there too.
Yeah, I think like generally what I think is cool about this question, as Harry said, it's like if you wanted to experiment about these things, experiment with some of these other protocol designs other ways without using layer 2s, it's like, yeah, either try to get a hard fork into Ethereum, try to launch your own L1, right? Like these are not really feasible things. Whereas now, like once layer 2 emerges, we can actually, you really do get the like permissionless innovation thing, even on the protocol level. So things that are like associated with more layer 1 protocols, we can experiment with on layer 2, which is cool. Of course, that's not like our primary goal. Like primarily, like yeah, we want scalability, we want cheaper gas. But the fact that we can try other data models, other protocols is I think an underrated aspect of the layer 2 ecosystem in general. Cool. Okay. Next question from Peep 2.0, who we see a lot of. Maybe he's even in the chat. I don't know. But he asks, are there any easy to use tools for devs to learn to migrate their contracts over to Arbitrum? Though this is one because the answer is basically we did not put out any to-use tools to help devs migrate their contracts because the tools already exist. Basically, all the same tools you use to deploy contracts to Ethereum, you can just use to deploy to Arbitrum. So Truffle, Remix, CSJS, Hardhat, it just kind of works. So I guess the answer is yes, there are tools, and they're the ones that you're familiar with. And this is something like we've gotten a lot of positive feedback from developers who've been using Arbitrum on our test nets, and yeah, we're really excited to be able to say that. So in terms of actually migrating, deploying, and running your contracts, it'll just work. We support every EVM opcode. We support anything you do in Solidity. There is a short list of I think it's like 5 or 6 differences in terms of Solidity operations between sort of what you expect on layer 1 and what happens on layer 2. And it's worth just emphasizing that like a lot of these differences really exist just because conceptually layer 2 is different than layer 1. So certain operations just don't make sense on layer 2, and we have to decide what to do with them. So the easiest example there is something like mining difficulty. I think the EVM opcode is difficulty. So, okay, on layer 2, we don't have proof of work miners. So like, what the hell does difficulty mean? And basically we just have to decide. In that case, we just return some constant. And there's just only a few other things like that. Gas, basically it's just denominated. It kind of works the same way. So all the opcodes will kind of work in an intuitive way, or all the solidity operations, but it's denominated a bit differently. So if you have like a hard-coded gas limit, you'd want to change that. Although if you have a hard-coded gas limit, you probably should want to change that anyway, because that's dangerous. And then timing is where things get a little funky. So things like block numbers and timestamps, because again, on layer 2, we just have to sort of rethink the timing relationship between layer 2 and layer 1. But the same basic rule of thumb should apply as using layer 1, where if you're making any sort of timing assumption about blocks on layer 1, your basic rule should be in the very short term, you shouldn't assume anything. Like on average, blocks are every 15 seconds, but in the short term, that could go kind of crazy. In the long term, it will average out that way. And the same is basically true of Arbitrum there. So yeah, really nothing too different you even have to conceptualize, but it is worth like considering these things and thinking about whether these affect your particular dApp. Cool, okay. Let's see, let's go with, okay, a question from Linkfather. Basically asking what will happen sort of to Arbitrum, or what are the implications for Arbitrum when ETH 2.0 comes along. Thoughts on that, Harry?
Yeah, so I think the first really important point to make here is that like ETH 2.0 is not like a single monolithic thing. It's a series of phases. So I mean, ETH 2.0 phase 0 is launched. ETH 2.0 is you know, one kind of core part of ETH 2.0 is already live, and there's already actually like some insane amount of ETH that's staked as validators to that chain. So, but that's not a chain that actually supports smart contracts at all, or has shards yet. So it's kind of a relatively small. It's basically just the kind of proof of stake part of ETH 2.0. So it's not kind of like practically useful. But and then there are kind of two other parts of ETH 2.0. There's ETH 2.0 phase 1 and ETH 2.0 phase 2. So phase 1 is actually something that we're really excited about. And phase 1 is sharding. So phase 1 is now, rather than a single chain, we have a bunch of chains that are all connected. But with the exception that those chains can't execute transactions. So all they do is basically kind of increase the amount of data that Ethereum is capable of saying, yep, this data definitely kind of exists and is in some order. But it turns out that's exactly what rollups need from the layer 1. That the main thing that Arbitrum uses Ethereum for is actually just kind of laying out and making sure that everybody agrees on what the transactions in the rollup chain are. So at that point in time, basically, that sort of extra throughput is kind of useful for rollups. It's not really useful for anybody else, because most applications of Ethereum are kind of, most of the cost comes from storage, using storage in the EVM, or kind of doing computation in the EVM and all of that stuff. And kind of phase 1 of ETH 2.0 is pretty useless for that. But kind of having a bunch of call data, having a bunch of data that's submitted and ordered by Ethereum, is the kind of the one thing that Arbitrum and that rollups in general need a lot of, and kind of ETH 2.0 phase 1 will scale that really well. So actually, rather than sort of like taking away the need for rollups, ETH 2.0 phase 1 actually is only really useful if you're using rollups, which is kind of like a really neat inversion there. Eventually, on the long-term Ethereum roadmap, I think they've even pivoted back and forth on whether or not phase 2 is even going to be worth it. Because there's a lot of unsolved problems there. I don't think people even know exactly how to kind of take phase 2 to completion. And it's not really even necessary, because phase 1 is going to be out way sooner, and rollups are going to be out and using it kind of well before any of the other phase 2 stuff is done. And so kind of, I think it's pretty likely to see a world where basically kind of rollups are really the only main way to kind of take advantage of the scaling that ETH2 provides, which is kind of crazy.
Yeah, it's like phase 2 is what it's adding on is sharded execution as opposed to just sharded data availability. But rollups are giving you sharded execution already. So yeah, there is going to be this weird question of why go that next step, which is really interesting. But yeah, we will be ready for phase 1 certainly.
And if
we need
rollups
to
are out and have tons of adoption well before phase 2, it's the chances of people like migrating off of rollups to seems pretty unlikely, given kind of that they provide really kind of the same level of security as the layer 1 does.
Exactly, and the benefit at that point to adding guarded execution to the to the core protocol get very abstract. You kind of want to do shared security with shared execution, but yeah, I don't know. We'll see what happens, but I think like part of why this phrase like rollup centric roadmap has caught on is because it's understood that, at least for a while, that will be what the ecosystem looks like, and that might just be sufficient. Okay. I have nothing else to add there. Well said, Harry. Moving on. Okay, so we got a number of intense questions from the inimitable Eric Wall. One of them is a good thing to clarify. This is getting sort of in the weeds, but I want to get this out there. So he sort of linked a picture to the old Arbitrum white paper, which is I don't know how many years old now, and he says that it contains a lot of wording around smart contracts being private. This is Eric Wall now, reading his words. I'm not privy to the exact privacy benefits of Arbitrum. There's nothing inherent in ORU design that speaks much of privacy to me. Can you explain? So let's clarify this. I don't know if Stephen, Ed, Harry, whoever wants to step in here. I don't know if Stephen's even there.
Yeah, hey, I'll jump in on this one.
Sure.
This is Ed. Yeah, so as Daniel said, Eric's question pointer to the Arbitrum academic paper that Harry, Stephen, and I, and some others published back in 2018. And the system that's described in that paper is different from the Arbitrum rollup system as it exists today. So let me talk first about Arbitrum rollup as it is now, and then maybe a little bit of historical context that talks about this privacy issue. So one of the thing that makes a rollup is that you're publishing on the L1 or making available enough data so that everybody can see, can understand all of the transactions that happened, right? So that's like all the transaction data, or maybe compressed data that it can be reconstructed from. And that provides transparency and trustlessness because anybody can follow along and act as a validator in the protocol. But of course, that is at cross purposes with privacy, because if you get to see everyone else's transactions and know exactly what they were and have the ability to dispute whether what the right result is, if you can see everyone else's transactions, well, then everyone else can see yours too. In the rollup product, there's not that notion of privacy. Now, and again, that's a feature because the trustlessness and transparency that rollups have come from the fact that that information is visible. Okay, so the academic paper from 2018 describes a slightly different version of Arbitrum in which participating in the protocol as a validator was permissioned. And in that permissioned system, the folks who are validators get to see everything, but people who aren't validators don't need to see every transaction that happens. And so that system could provide and did provide a privacy guarantee, namely that the validators of a chain would see what in the paper are called managers, get to see what's happening, and other people, but the contents of transactions can be kept private from other people. So that's a little bit different than what we have today. I'll talk about this a little bit later, maybe in the Q&A. We talk about the early history of Arbitrum. The original version of Arbitrum actually comes from 2014 and was more like a rollup. So right now we're on a rollup-based product. In the future, our roadmap I think will take us to future products where there are stronger privacy guarantees. But right now we're on this rollup, and transparency is inherent to what we're doing.
Cool. Yeah, and there's a lot of neat features about this alternate version. This future version. Not only can you get privacy guarantees, but it turns out like the base layer, and I mean this is sort of true now, but the actual functionality required from the base layer is actually very limited, which just like has all sorts of cool implications, even for like possibly running things on on different L1s. This is one of these things that just like hasn't really sunk in yet in the community at large. But yeah, there's a lot of cool stuff to explore there. I'll just leave it at that.
And you can, and the other just like thing to toss out there for people to think about is that when you don't, if you move away from a roll-up model, if you then you don't necessarily need to post as much data on one chain. You can reduce costs a lot actually by moving to different sorts of models. And obviously there's trade-offs there around trustlessness and performance and so on. And down the road, we're going to be offering variations on the basic Arbitrum technology that let people do those trade-offs in ways that they want, with some really interesting and innovative approaches to combining trustlessness and privacy. But that is in the future. Right now, we're really focused on Arbitrum rollup and getting that delivered and on mainnet.
Cool. All right, next question from Felonius Nabokov, great name. Any plans to incorporate NFTs into your optimistic role? So in short, yes. And I can talk more generally about sort of bridging tokens or bridging assets. The thing to understand is, something like Arbitrum, truly, I can literally say I can support any token standard, including token standard that don't even exist yet, right? And this is because we sort of, the way bridging assets works on Arbitrum is we sort of have this very general system for interchain communication. And we've gotten a lot of, a lot of devs have been using this for various hackathon things. We've gotten some questions on this lately, which is great. But essentially, we have this generalized ability to say we can have the L1 kind of trigger a contract on L2, essentially. We can have the L2 trigger a contract on L1. And both of these are generalized. There's little caveats in here in terms of asynchronicity and timing, but essentially you can do those two things. And those things are sort of part of the core protocol. And then from that, you can just build whatever applications you want around that. And token bridging is an example of this application. So you can see now we built a sort of fungible token bridge where you can sort of bridge any ERC20 from layer 1 to layer 2. Anyone can build their own bridge that sort of does the same thing, right? And yeah, so yeah, but there will be an NFT bridge. Probably it'll be out when we initially do our mainnet launch. If not, someone could just build their own, right? So this is just like one of the neat things is that the actual, in terms of what the protocol recognizes, in terms of the things that are built into Arbitrum itself, it's actually fairly limited and simple, and we can build around that. What's nice about this is we can, if we want to add new token support, let's say, it's not as though we have to like update the Arbitrum protocol. We can just build it as a dApp. So that's a long way of just saying yes. Question from @Canucklink. What role is the Graph protocol playing on Arbitrum? Basically, we can support the Graph protocol. For those, oh wow, we've got a number more people joining. Hello and welcome to the new people. For those who aren't familiar, the Graph is basically just a system for indexing and querying data on the Ethereum blockchain. And yes, Arbitrum supports it. We've used it in a number of dApps that we've used in our testnet. We use it, in fact, for our block explorer, so we can confirm Arbitrum supports the Graph. Question from the Cube Collector wants the Cube Collector wants more detail about the Chainlink integration and how it works and when it will be available. You want to take this one, Harry?
Yeah. Happy to. Yeah, so there's like a few there are kind of a couple different main kind of things I think about there. The first is kind of like, I'll say the more obvious of the two, which is kind of with dApps moving into L2. I mean, oracles are obviously like a kind of crazy important part of like most of what goes on in Ethereum. And like with applications migrating to L2, kind of having Chainlink migrate with them is kind of foundationally, extremely important. And kind of the kind of unique twist that layer 2 provides lines up really nicely, which is to make transactions cheaper and faster. Because what you can do if you have cheaper and faster transactions is you can have kind of Oracle updates occur more quickly at reasonable costs. So I think kind of like basically the L2 transition will provide the opportunity to make a lot of kind of types of data feeds feasible that just wouldn't be anywhere near as feasible on layer one because of kind of the slowness and expensiveness of the base layer. And so that's kind of, one side of things. The other big side of things that I think has me personally quite excited is that is the idea of kind of reporting back information about what's going on in the Arbitrum chain to Ethereum. One of the kind of big design constraints of kind of optimistic rollups is basically that Ethereum to Arbitrum communication is very fast, but Arbitrum to Ethereum communication has to wait for the optimistic rollup dispute period to elapse before it can go through. And so that's what that means in practice basically is that kind of for a low level transaction to go from the Arbitrum chain to the Ethereum chain, it takes a week. But there are a lot of cool ways to mitigate this. There's some kind of particular solutions to fungible tokens that can kind of be done completely trustlessly. Without kind of any sort of like just purely kind of at the smart contract layer using kind of just like application design and cryptography. But that's kind of a very specialized use case. And so kind of that doesn't handle a lot of things, but there's a lot of applications that I think are quite exciting. So like, for example, let's take kind of one simple example, which would be a DAO in layer 2 that wants to control things happening at layer 1. And so the DAO takes a vote. It has the advantage of kind of being able to vote much more cheaply on layer 2. It comes to some decision, and then it wants Ethereum to know about its decision. Well, if you're using kind of the regular bridge to communicate data back to Ethereum, it's going to take a whole week for that decision to be communicated, which might be okay for some use cases, but isn't very good for others. Whereas if you have an Oracle, which can just kind of run an Arbitrum node and deterministically know what the result is immediately, because everybody running an Arbitrum node knows what's going to happen, just not Ethereum. The Oracle can just report back the result extremely securely back to layer 1 and be able to get that result very, very quickly. And so I think kind of this design space of basically kind of having oracles be kind of a kind of key part of the interoperability layer between kind of Ethereum and Arbitrum is kind of an area that kind of has me pretty excited.
Yeah. Cool. Yeah, and basically, right, like Harry said, for all of these sort of slower L2 to L1 things, if you're doing something fungible, you can sort of skip ahead and do this like atomic swap trick, so you don't have to wait for anything else. Yeah, have a trusted oracle. There's some party they can offer you. They can just sort of provide that information directly. They can also provide like crypto economic guarantees. So security guarantees that are kind of orthogonal to the Arbitrum protocol itself, but for a lot of use cases, that's sufficient. So yeah, definitely infrastructure like Chainlink is valuable for that reason.
Yeah, and just to rephrase kind of my answer slightly in a shorter form, well, the first part of that answer is basically all the things Chainlink is doing on Ethereum already are just bigger and better on Arbitrum. And the second part is essentially kind of like a whole new area of data that kind of doesn't exist today, which I think is kind of ripe for kind of Chainlink providing access to.
Cool. Before we go to the next question, I realized we did intros at the beginning, but Stephen and Ed joined a bit later, and these are arguably important people at the company. So why don't we do intros there? Stephen, you want to just step in and introduce yourself?
Hey everyone, really great to be here, and thank you all for joining. I'm Stephen. I'm co-founder and CEO of Off-Chain Labs, and yeah, really happy to answer all your questions, and thanks for engaging in general. Yeah, so just I guess a quick personal background. I got into the crypto space in around 2013, and together with Ed and some others at Princeton, I wrote a textbook on cryptocurrencies, as well as also did a lot of work on thresholds cryptography that's used by a bunch of players in the space. And Arbitrum was sort of late in my Princeton PhD careers when Ed, Harry, and I started working on Arbitrum together. Ed, of course, as he'll tell you, I've been working on Arbitrum for years before I got involved. And yeah, and in the interim, I actually did a postdoc with Ari Jules, who is maybe known to some of you because he's also the chief scientist of Chainlink, and we had the opportunity to work together quite closely there on some projects, including fair sequencing and Deco and some other projects. Ed, do you want to take it from there?
Sure. Hi, everybody. I'm Ed Felton. I'm the third co-founder of Off-Chain Labs and chief scientist. And as Stephen said, I spent a good part of my career as an academic, as a professor at Princeton in computer science, and started working on cryptocurrency blockchain research around 2013. In fall of 2014, I supervised a group of students who were building what we would today call a layer 2 or roll-up type thing, which was dubbed Arbitrum. So that was the initial Arbitrum in fall of 2014. You can actually go on YouTube and see the students talking about their course project at the end of the semester from back then. So in addition to being an academic, I've done 3 tours of duty in the US government, most notably in the White House from 2015 to 2017, where I was deputy CTO of the US government and a senior advisor to President Obama. After that, I came back to Princeton as a professor, and one day Harry and Stephen walked into my office and said, hey, you know that Arbitrum thing? We should work on that again. And one thing led to another. We published an academic paper that I talked about before in 2018. We knew right away, I think, that scaling technology for Ethereum was going to be a big deal, that scale and transaction costs were going to be important, and that we actually had something that was really useful for addressing it. And so that's when we founded the company. I have been since for almost a year and a half now, full-time at the company, and this is now what I do. So, but enough about me and us. Let's get back to the question.
Cool. Thanks, guys. Just wanted to get those intros out of the way. Yes, back to the questions. So, there were a number of questions about this issues around transaction ordering and MEV extraction, which has been sort of the big hot topic lately in the Ethereum world. One question from at 42 was, how will Arbitrum help to improve the situation when it comes to order front running and sandwiching? So this is a huge topic. I don't know what angle we want to take on this, but I'll hand it off to Ed, and then else wants to chime in.
Yeah, so the short answer to this is that our sequencer technology is going to be really helpful when it comes to dealing with front running and this MEV extraction problem, right? And of course, the problem there is that on Ethereum and really any proof of work type system, miners have a lot of ability to reorder transactions, both in order to put themselves in advantageous positions, which is another way of saying putting you in a disadvantageous position, or just selling off transaction ordering rights. So the users find themselves in a position where either you get disadvantaged or you have to pay just to get fair treatment of your transactions, fair ordering. The sequencer, which we'll have on our mainnet launch, does 2 things for you. One is it addresses this issue Harry talked about before, the user experience challenge with Ethereum, where it takes much longer than people want to get finality on your transactions. The sequencer will be able to promise you the result of your transaction right away. So you get instant finality where you know what the result will be. And then that gets recorded on the chain and recognized later. But the other thing it does is that the sequencer will determine the order of transactions rather than whatever miner happens to make a block. So in the very beginning, the sequencer will be operated by us, by Off-Chain Labs, and I am raising my right hand and swearing right now that we will operate it fairly, that we will put transactions on chain in the order they're submitted to our sequencer. You'll be able to look at the open source code of our sequencer and watch what we do, but that's what we'll be doing early on. Over time, though, we'll be transitioning to a set of technologies that let us decentralize the sequencer. And this builds on work that Stephen Goldfeder, my co-founder, colleague, and Ari Jules and a bunch of others have done to develop fair sequencing technologies. And the basic idea there is you decentralize the sequencing so you have a committee of parties who act as the sequencer. And as long as some quorum of that committee is honest, then you'll get fair sequencing. So that is the direction that we will be heading over time. We have some really exciting and interesting research that is going on along those lines to develop even better fair sequencing methods than the ones that have been published so far. But basically the answer is our sequence. My own view is that MEV extraction and front running are a significant issue, and and we're happy that we're going to be able to offer a solution on Arbitrum that is less prone to that problem than Ethereum.
Yeah, it's funny how this discussion in general in the community has gone in some pretty interesting ways, and it seems like not everyone even agrees that fundamental principle that like MEV extraction, all things equal, is not a good thing. But I think that's that's certainly my view, and I think that's the view of everyone here, which is to say, if there is a way to minimize it, that's a good thing, and it's exciting.
Yeah.
That, we may be able to have a layer 2 where it's actually minimized relative to the layer 1 underneath it.
I mean,
so that's
So the deal with, the key word in MEV extraction is extraction. And in general, if you're not doing the extracting, then you are being extracted from, and that means it's costing you money. This is not money that's extracted from nowhere, it's extracted from users. I at least think it's a bad thing if users are getting funds extracted from them in their transactions or have to pay for fair treatment. That's not how we want to do things.
Cool. All right. So unless anyone else, no. Okay. Cool. Shifting gears a bit, we got a few questions sort of about the business end of things. At Victor, with a lot of underscores in his name, asked, how are you approaching user acquisition? So we can, AJ or Steven, either one of you wants to kick that off.
Yeah, sure. Steven, do you want to take it? I can take it.
Go for it.
Yeah. So for user acquisition, the majority of our efforts are really focused around sort of, figuring out, what developers and dApps, need for deployment on Arbitrum. There's the component of, the easy portability onto Arbitrum, but there's also, dependencies that it need. We spoke a lot about oracles. We spoke a lot about the graph, block explorers, node providers. So all of these sort of different things that the community needs in order for both the dApps and the end users, wallet support, for example. So we're really focused on a lot of those things, as we build out the ecosystem. As we get closer to mainnet launch, we're going to have a lot of, announcements around different sort of infrastructure providers that we're working with to help sort of bootstrap the ecosystem. So stay tuned for that. But it's really working with developers, and if you're a developer in the audience, and I see a lot of names that I've actually spoken with, definitely feel free to DM me if you want to speak with the team, have any questions. Happy to set up a call. But it's really we're thinking about this as working with developers and dApps that are thinking of launching on Arbitrum, and to be our partners in this migration to layer 2 to ease congestion.
Cool. Yeah. Anything you want to add, Stephen? Or
No, that's great.
cool. Okay, let's talk about other layer 2 protocols. So this is where things get complex. To truly. So we had a number of questions asking about sort of the trade-offs between Arbitrum and some other systems. Polygon got mentioned. ZK Sync got mentioned. Optimism was mentioned. Sort of why pick Arbitrum over these, or what are the trade-offs between them? We had questions from Linky's Leaks about this. I think he's going for like a WikiLeaks thing. No Sleep John also asked about this. So yeah, so I've written a fair amount about different layer 2 constructions. To really sufficiently go into this takes a while, as in probably like a semester. But let's see if we can scratch the surface. So I'll kick it off, and let's talk about Polygon, which is another project. So Polygon, so they're sort of doing a lot of different constructions. They're like building all these, a wide range, like a whole layer 2 suite. I'll talk about what they've released already, what's on mainnet, which is their Matic chain, and sort of how that compares to Arbitrum and what are the trade-offs between them. So with Arbitrum, we didn't really say this, by the way, but we should just say briefly, Arbitrum is, optimistic rollup, which means uses layer 1 for data availability. So there's always enough data on chain to reconstruct the state of the Arbitrum chain. and fully trustless, fully permissionless, and it enforces safety via fraud proofs. Okay. With Polygon, there's sort of the Matic chain, again, what's currently on mainnet. It's sort of two systems in one. So they have this proof of stake sidechain, and then they have a Plasma MVP chain. So the proof of stake sidechain, the idea here is the validity of the chain, instead of sort of inheriting security directly from Ethereum layer 1, it has this sort of separate environment and a separate security system, which is to say there's these validators running this proof of stake system. So the pros here is that you don't have to sort of store all this data on chain. So there's a throughput benefit, maybe a gas cost benefit. The downside, again, just comparing it to Arbitrum, is you don't get that direct L1 security. So there's a trade-off there. And for certain use cases, I mean, at least my view, and I think our view generally, is that like there will be a wide range of L2s with different security assumptions. And that's fine. The other way to use their system, the other way to use their Matic sidechain, is there's this like Plasma bridge, Plasma MVP, more in particular. So this kind of feels a little more like an Arbitrum style system in that it is inheriting security directly from layer 1. So you get that trustlessness. It's non-custodial. There's no like different security assumption. Here they are. So the pros versus something like Arbitrum is that they're keeping data off chain. So again, you're not bottlenecked by layer 1. The downside with this Plasma system is, forgive me if any of them are listening and this is off, but give all of their MVP chain support. Is simple token transfers, but we can. It's predicates. You can get some smart contract functionality, but it is not generalized smart contracts. I think we can say that much. But yeah, I won't say any more than that. But yeah, so that's kind of how Arbitrum compares to what Polygon is currently offering. And I know that they'll be releasing more different constructions, including I think some roll-up type stuff. Okay, so the other one was ZK rollup, particularly ZK sync. Maybe Harry, do you want to step in and start talking about the differences there?
I'm happy to, unless Stephen wants to grab that either.
Oh, sure, yeah.
Either way.
Sure, I'm happy to take that. So, the question was ZK rollup. Is that correct?
Yeah, ZK. Yeah, exactly.
Yeah, ZK rollups, well, ZK sync in particular, or ZK rollups.
ZK sync in particular, and the trade-offs there versus.
Yeah, so fundamentally, there are a few things to be said here. Number one is basically, what Arbitrum is today is a working system that gives you EVM compatibility at the most fundamental layer. Like we're actually compatible with EVM smart contracts on the bytecode level, and this is the experience we provide, which means your contracts on Ethereum, they basically, in almost all cases, just run out of the box in Arbitrum, and actually with some extra goodies, like you don't run into the same gas limits and contract size limits. And that's basically what we went after, is making the experience as close to Ethereum as possible, and fully compatible with Ethereum tooling as it is today. Now, ZK rollups. So if you back up a little bit, ZK rollups. I guess I'll say historically, there's that much history there. The whole space is not of rollups is maybe 2 years old, not even, I think. So historically, these are viewed as more for payments, and that's what's running today. For example, ZK Sync has payments running, and those work quite well. And basically, what ZK rollups do is the fundamental on a technology difference is, whereas in both systems you move execution off chain. In both systems, you want the layer 1 security. You want Ethereum security, so you need to prove to Ethereum what happened off chain. The question is, how do you do these proofs? In the ZK system, you give what's called a validity proof, which means you say, hey, here's what happened off chain, and here's a proof what happened. In an optimistic rollup like Arbitrum, instead you say, hey, here's what happened off chain. I'm going to post it optimistically. I'm not going to give a proof, but someone else can come in and give a fraud proof. So a window opens up for the fraud proof to occur. So that's a fundamental difference how these technologies work. But there's under the hood, it turns out that fraud proofs are much more easy to implement and don't require complex cryptography, whereas to do the validity proofs, you use these expensive proving constructions. In fact, they're called ZK rollups because these proven technologies are ZK snarks or ZK starks, which are zero knowledge proofs. It's actually a bit of a misnomer because the part of the proof that you care about is not the ZK, not the zero knowledge. It's not the privacy. Everything's public in these systems. It's actually the succinctness, the fact that you can prove succinctly about what happened off chain. But anyway, backing up for a second. So the state of these systems is they work really well for payments. That's what we're seeing that ZK Sync is running on mainnet today. They work well for some application-specific systems, and we see Starkware is running this today. No one's basically proven that no one's put out a system that can take arbitrary smart contract or arbitrary EVM computation. There are some claims out there that things are coming, but no one's actually put this out yet. So, and there's very, very scarce technical details to accompany these claims in terms of what are the benchmarks, what are the proving costs, what does EVM compatibility mean? Lots of different projects can say that they're EVM compatible, but there's a spectrum here. We're fully compatible on the bytecode level. There's really a spectrum here. So what I'll say is, the things to look out for and the places where Arbitrum really shines is, one, we have the full EVM compatibility, so the tooling all works, and the other is that the costs of running Arbitrum are very close to the metal, right? So running an Arbitrum node is not very computationally expensive, and there are some significant benefits there. Whereas the cost of compiling arbitrary contracts from EVM, if this compiler does exist, that I haven't seen it, but if it does exist, then and apparently it does. What are the efficiencies of this compiler? What inefficiencies does it introduce, both at the compilation level and at the proving level? And again, these are open questions. But what I can tell you about Arbitrum is that we run very, very, the cost of proving on Arbitrum is very low, so anyone can run an Arbitrum node. It doesn't tend to centralization. You have to have very expensive hardware to run one of these nodes. And that's so basically what I'd say is, to the extent that you want something that runs EVM smart contracts efficiently today, Arbitrum is basically the farthest along here. And our systems are running on testnet for the past 6 months with these capabilities. So that's basically how I would characterize that. What the future brings is, like every other protocol that we've seen, there are EIPs in Ethereum, there are BIPs in Bitcoin, and Arbitrum will be no different. There will be upgrade capabilities, and to the extent that in the future, there is something that's a good idea for us to upgrade Arbitrum to, be it zero knowledge, be it some other technology, you can be sure that we'll continue to innovate on Arbitrum.
Cool. Thank you, Stephen. So as for there were again the other protocol that got mentioned was Optimism, and here we got some from again more questions from Eric Wall, some very in-depth questions about generally how Arbitrum uses multi-round proofs and comparisons with that versus sort of single round fraud proofs. Particularly why Arbitrum doesn't require as many state root commitments. Are there cases where a single round fraud proof is ever very expensive? Are there any sort of unexpected second order side effects due to our design decision because of these? These are very good questions. In fact, they're so good and that there's no way we can do them justice in 10 minutes. So big tease. We're going to do a separate, after this, at some point we'll announce a separate session where we kind of focus on this exact thing. Why multi-round proofs, multi-round versus single round, and really dig into those details. So be on the lookout for that. And thank you, Eric Wall, for the wonderful questions. One more thing on the sort of like layer 2 ecosystem stuff. We got a question from 2 a.m. researcher, I like that, who asked whether we think that layer 2 solutions will be a winner takes all arena. You want to give any thoughts on that, Harry? And we've discussed this.
Yeah, totally. Yeah, this is a question that comes up fairly often. Obviously, there are a lot of there are kind of a bunch of different solutions being worked on right now in terms of kind of layer two scalability. I think you know many of which have already been mentioned. I would say there's a couple different parts of this. One place I like to start when talking about this is kind of in terms of like our long term vision for the space, which is kind of expressly not everybody on a single rollup chain. Because if everybody is on a single rollup chain, then that chain is really, really, really expensive to verify, to run a node for. Because you somehow are kind of in the same situation as Ethereum, just like kind of running an Ethereum node is relatively expensive. If there's an Arbitrum chain that has kind of enough throughput for everybody in the world to use it, then it's going to be really expensive to run a node. So in kind of like the long term, and this is kind of not, this is, in the short term, one chain is what makes sense. But kind of as time goes on and more kind of new users join Ethereum as kind of, as blockchains really do become kind of global and commonly used, the kind of the ecosystem is going to have to kind of move to a kind of multi-rollup world. Where kind of there are different chains, probably kind of based on use cases and based on kind of what needs interoperability with what else. And so kind of, I think the long-term vision is kind of in no way ever going to be a single rollup chain. Then of course that brings you to the question of, well, what tech are these different chains running on? I think a bunch of them may be Arbitrum chains, I think we have some great tech. But there's kind of a lot of opportunity there. And so there's a lot of kind of, different rollups are kind of focusing on and specializing for different use cases, for different kind of user experiences. So I think kind of once you've committed to like this idea of like, there are probably going to be more than one rollup chain, there's kind of a lot of room for kind of different approaches that have kind of different pros and cons to each other. And so, I would expect that, for quite a while, we'll be seeing that, most likely.
Cool. Okay. We're getting low on time, so let's go to lightning round. Most of these should be quick, although some of them, we'll see what we can do. Okay, we got a question from Dry Blanket. It was asked in French, and I'm not going to try to pronounce it, but according to Google Translate, this translates to "Who thought of the name?" Who came up with Arbitrum? We can go to either
I'll jump in because I was present at the creation. So the answer is I don't know who specifically it was. I can tell you it was the fall of 2014. I can tell you it was a bunch of students and me sitting in a circle around a table in my office at Princeton. But I can't tell you which person suggested the name Arbitrum first. We had a naming brainstorm for the project that they were building, and someone came up with this idea, and that's what we settled on. So fall of 2014, my office, I don't know who.
The other thing to add in here, which I think is not obvious to a lot of people, is where the name comes from, which it comes from arbitration, not like arbitrage or arbitrary or any of that. Because kind of it was based around like the kind of the way that challenges are resolved by kind of by Ethereum mediating a dispute between different validators.
Yeah. We've learned
Yeah, so what we currently call the ETH bridge L1 contract that kind of referees disputes between parties was way back in those days. We often called it the arbitrator. Not really a good descriptive name, but that was the germ of the name Arbitrum.
Yeah, we use like the ARB prefix for stuff sometimes. We've learned that sometimes people assume that means arbitrage, so we try to avoid that for things like variable names and contract names. But yes, arbitration. Okay, let's go to Harry for this one. What is the most surprising thing you've discovered while building Arbitrum? I like that one.
Yeah. I mean, it's somewhat petty, but the degree to which the Ethereum RPC interface is not very well documented. But there's a lot of stuff in kind of that like in Ethereum land, like as we've kind of tried to strive for kind of having Arbitrum be as compatible with Ethereum as we possibly can. A lot of the kind of places where we found out Arbitrum wasn't compatible, which have been resolved now, are places where like the expected behavior wasn't really actually documented anywhere particularly nice. And so that's one big one. I think the other kind of interesting one is basically just sort of like all of the kind of shifting around of kind of design methodology of kind of like what it means to build an L2 versus what it means to build an L1, and kind of like all the ways that kind of like people's thinking shifts as they kind of think about kind of, the various different kind of benefits and constraints and design surrounding layer 2. And so kind of like, all of like dealing with all of, one awesome thing there, which I think, I mean, a lot of people in the state channel world probably did see this coming, but like, for a while, it kind of seemed as though kind of state channels were a bit on the way out, that essentially they did like, it's the oldest type of layer 2 scaling. And I think kind of really there were, pretty significant issues with traction for a while there. But like with rollups rising up kind of out of nowhere for me, we suddenly got to this world where it's like, holy crap, like channels are like, key to this future, to kind of providing interoperability between solutions. So that one was definitely one, and I've loved channels for a long time. It just seemed like they were really struggling with like finding use cases. So that one was actually probably my number one there in terms of kind of very pleasant surprises.
I think just in terms of like grokking the protocol, for me, the part that was surprisingly in depth and like layered is just understanding like handling gas on layer 2. I think in my mind, having done like protocol research and things like that, I just hand waved over a lot of the details. But actually getting, handling gas in a way that's economically sensible and like technically plausible is actually a really interesting challenge. And I think, I think our system does it. But yeah, and we have it all documented now. But yeah, ARB gas is sort of its own fascinating topic. I guess similar question. I don't know if you have any like different answer here. I guess Ed could chime in too. But I really like this question too. What thing that you found harder to implement than it looked in theory? I'm very curious. Like, I would love to ask this to every project. I bet you'd get fascinating answers. But so similar thing about what's surprising, but particularly in terms of the implementation details. Does anything come to mind there, Harry and/or Ed?
I guess one surprise for me is how many weird corner cases there are in the Ethereum and EVM specification. The yellow paper is like a giant mass of corner cases. And having done the exercise of implementing something compatible, I was surprised at how much of that there is.
Yeah, no, that makes sense. That question was from Jay Swag, by the way, I forgot to say the names. This next question is from @RealityHitter, which is who's the biggest workaholic? Yeah, go ahead.
To throw in for that one too, which is like basically reorgs. That like,
oh yeah, that's a good one.
Yeah, like most Ethereum dApps kind of deal with reorgs basically just by like kind of saying, well, we're gonna wait to really take the effects of your transaction until it's buried a few blocks deep. We're gonna wait for some number of confirmations until it's like relatively unlikely for it to be reorged. But like for Arbitrum, it's for an L2 chain that's actually kind of like trying to like relatively like live interact with data that's being posted on Ethereum. You have to really carefully deal with reorgs, because you can't just take this approach of like sitting back and waiting. You have to kind of like take the data as it comes. And so like actually in practice dealing with that sort of like the ground is shifting under your feet feeling of like you never know when the like latest kind of few blocks might totally change is is one of those sort of engineering problems that's a whole lot of pain sometimes.
Yeah, there's a lot more subtlety, and I think it took us a while to figure out how sort of a framework for dealing with the reorg challenges. In particular, the fact that your data is recorded on the L1 chain, but the computation that happens is happening on a logically separate L2 chain, and making sure that those don't get out of sync. We have a really solid approach to doing that, but it took us. But it's a really subtle problem. It took us a while to figure out.
All right. So @RealityHitter asked, "Who's the biggest workaholic amongst the team?" I can sort of take this one. I feel like there's definitely a lot of competition here. It's definitely. I think it's as is often the case. It's sort of split among the founders, I would say. I might have to go with Harry because sometimes I'm pretty sure he just doesn't sleep.
Wait,
And
actually,
it's
is that a good thing? I don't know if I should celebrate because I'm not sure if it's a good thing.
It's a skill. I mean, it's a skill to like. There's definitely times when I'm like, wait, I see the timestamp of commit messages, and then like messages on Telegram and on Slack, and I'm like, did you like nap for 15 minutes twice? Like, literally, mathematically, I don't know when he slept. So
I'll tell you one thing. I'll tell you this: that between the team, we definitely have, and this is, well, we're geographically distributed. We definitely have 24-hour coverage. You can probably, if you look at the commit history, see that Harry will commit something before he goes to bed, and Ed will commit something right when he gets up, and those two things might overlap, right? So
And I go to bed pretty late, and Ed wakes up pretty early. So there's
right, yeah. 24-hour coverage for all things. Okay, next question at 2 a.m. researcher, which is who is your coolest dev? I feel like anyone can answer this because it seems pretty
Daniel.
obvious to me. Yeah, no, that was just a freebie. Moving on.
nice.
Another one from at.
I mean, I don't know. I think it should really be. You know,
I'm sorry, Jim,
who's your biggest Twitter troll?
Right. I mean, that's even easier. Yeah. No one asks who's behind, the sort of some of the company tweet accounts. But that's yeah. I'll just leave it at that.
Oh, that is a good question.
Yeah, that's a good question for next time. Okay, we're going a little bit over, so I want to just get a few more in. Linky's asks, if you were trying to impress somebody, what aspect of the Arbitrum protocol would you describe to them? Steven, do you want to take this one?
Sure. Yeah, I would basically, as an academic, it's funny to impress someone. Like, okay, so this is, let me just step back for a second. Generally, the way, when I find when people want to impress people that aren't in the academic world, they'll look to complexity. And my years in academia have made me look to simplicity. So when someone shows me a paper, for example, with this crazy complicated chart, that's less impressive than a simple chart that I can understand. So in that vein, again, I would think that the simplest part, the most impressive part of our system is the fact that it literally just works with all the tooling you already use, right? So, I could point to all the complex things under the hood that make it work. But to me, the most impressive part is the fact that it just works. That you can literally take your whatever tooling you're using. So hard hat, truffle, brownie, it doesn't matter, and you just literally plug in an Arbitrum RPC node, and everything just works. I think that is by far the most impressive feat. And again, it's because it makes it clear all the complexity underneath to make that happen. But to me, it's the high level, this just works, and we take all the complexity away from the user that I think is the most impressive. And I remember when that happened, this wasn't always like this, so we put out the initial version of Arbitrum last February. So, well, a year ago February. So a year and a half ago almost, or a year and a bit. And we had this custom compiler, and we had a bunch of differences from Ethereum, and it took us a while to get there. And Ed really championed ARBOS, and it was really over early summer last year when it was everything, all the different pieces, Harry and Ed were tunneling at each other, and everything sort of just came together. And it was really an aha moment, and wow, just deployed straight EVM bytecode, and everything just worked. And that to me, I think, is the most impressive feat the thing that we have. Again, other than the team, if anyone else in the team wants to weigh in here, please do. This is a completely
I want to go with
subjective
something. I want to go with something nerdy and technical. So basically, the opposite, which is so when we talk about dispute resolution, when we're hand waving around it, we're okay, so you present some an assertion over some data, and then if there's a challenge, you cut it in two parts. So there's the first half or the second half, and then kind of the person on the other side of the challenge can if the first half is wrong, they say okay, the first half is wrong, and then you bisect that, or they say the second half is wrong, and then you bisect that, and kind of we describe it that way, A, because that's what it was originally, and B, because it's a hell of a lot simpler than the actual scheme, because the actual scheme is many times more efficient. You're you're not cutting it in half, you're cutting it into a ton of pieces. You're not choosing a part to that you think is wrong. You're actually you're both people are bisecting each other's in this crazy complicated dance. The end result of which is being able to cut down to a single instruction in a shockingly small number of rounds. Which is a whole kind of series of innovation we did as we were okay, let's make this more and more and more efficient. So yeah.
Yeah, I would have also gone with something complex and nerdy. I was thinking like just the whole notion of ARBOS is itself like a really neat technical marvel. Just the fact that like we have the state machine, like we can do Ethereum like stuff, have transactions and contracts and so on. But then there's this like system level functionality, and that also compiles to the AVM, and that also runs on L2. That's just like super cool. But yeah, I mean, I think the question's about trying to impress someone. So I guess it really depends, like in what context and who you're trying to impress. As for what you would emphasize. Okay, we're sort of over time. Let's just do one more. And we kind of already touched on this, but might be just a good place to end, even if it's a little bit of recap. But from @John Nostalge, I guess. What are some of the interesting things that Arbitrum has in mind for future roadmaps? I don't know who wants to take this one. Ed, maybe you want to steer this one.
I could throw some things out there.
Yeah.
In terms of like, what are directions that we can go? One of the advantages of the way that Arbitrum is architected is you have a ton of flexibility to change how programs are provided and what the execution model is. So for example, being able to run programs that are written in WASM and run them alongside and interoperating with EVM contracts in a really natural way and without needing to use super creaky compiler technology. That's something that's on the roadmap. We have a bunch of things I alluded to earlier around relaxing the data availability model a little bit in order to get really big reductions in cost and improvements in scalability, and also to provide privacy. There's some very cool privacy things that are coming down the road where if you have a contract that has a limited set of participants, you can make it so that only those participants need to know what's inside that contract. And to do that in a way that is, again, interoperable with what exists. So there's a lot in terms of, and then finally there's a set of capabilities that we can add as things like precompiles. And we have some really cool things here that that really open up the model and can dramatically change the cost structure for application developers. So really, there's an open field. We're going to be doing a ton of stuff once we're launched and established on mainnet. So just some
Awesome. All right. Thank you, Ed, and thank you all for joining. Two important things before you go. So again, we'll be doing another one of these same time next week. So that's 2:30 EDT. And basically, because we got a number of questions about multi-round proofs versus single round, there's really no way to go into those without sort of explaining, the whole protocol to kind of get at the core design rationale. So we're just going to do that, but that's going to take that's going to take more time. So we're going to devote a session to that, the question of why multi-round proofs, and we will answer a number of the questions that we got on Twitter at the same time next week. The other thing to say is we are hiring, so yes, for anyone listening, if you are interested, please reach out to us. There's a number of positions open. And was there anything else you wanted to add there, Steven?
Yes, sure. So,
okay.
Basically, yeah, a lot of you are asking when we will launch our mainnet, which is seems like a really good question. So, for those of you not to get too excited, I'm not going to say a specific date right now. So, but we very much believe in announcing specific timelines once we are fully ready to commit and to them, and that's basically how we operate. And so what I can say is we will be launched quite soon, and we will be making an announcement about this quite soon. And what you can get from us is when we announce a mainnet date, we will deliver on that date. And so watch out for our Discord and our Twitter for announcements coming quite soon. And I'll tell you that the mainnet is coming soon, but we will get a lot more specific about this also publicly soon as well. So sorry for not answering the question to the way that I know that there are a bunch of our Discord that really want me to commit to a date right now, but I can tell you that the date will be quite soon. you won't have all that much notice, so we're not going to announce a date months away. We will be there though. We will be announcing quite soon, and the date we announce will be quite soon after that. So we just leave it at that for now. And you got to leave a little bit up to mystery. I don't want to steal our thunder too much. So yes, please stay tuned. And yeah, just to reiterate what Daniel said, we are hiring. I think Daniel said that we are hiring. So please, if you're interested, you can go to our offchainlabs.com, reach out to and apply on our jobs board. But also, if you think you're like totally the right person for the team, and you can also feel free to skip that and just DM me directly on Discord, and we can fast track your application. We've done this with a few candidates in the past. It works quite well, and we can just basically fast track that as well. So please, looking forward to a bunch of messages after this session.
Cool. Thanks again, y'all. And yeah, same time next week for part 2.
All right. Thanks for being here.
Thanks, everybody.
Bye-bye.
Take care.
Bye-bye.